Question 7a. A car starts from rest and then travels for 70 seconds as shown in the graph in figure 11. That's the rest, 70 seconds, time in seconds. The y-axis is velocity in meter per seconds. This is a velocity time graph, and the line here is constant acceleration, uniform acceleration, steady acceleration. Same word, same meaning. Constant, uniform, steady. Here is constant velocity, because this is a velocity time graph. Horizontal means constant velocity. This is deceleration. That's a negative acceleration, so that's deceleration. Again, steady, uniform, constant deceleration. Complete this sentence using data from figure 11. The car is traveling at constant velocity from, so we know what constant velocity is, right? Here is the constant velocity from 20 seconds to 45 seconds. So we have to put in there 20 seconds to 45 seconds. Part 2, use data from the graph in figure 11 to show that the car travels a total distance of about 710 meters in 70 seconds. What that meant is we need to find the total area under that graph. The area under the velocity time graph is the distance or displacement. We need to split that into 3. This is a right angle triangle, rectangle, right angle triangle. We know how to find the area of these 3. That's the h for the height. Same thing here for the height. And this one is the base. That's the base. That's the base. So we're going to call that base 1. That will be base 2, base 3. And the area here will be a half base 1 times the h, and the area here is base 2 times h, and the area here is a half base 3 times h. Now we need to populate it with the values. As you can see, the height here is 15. The height is 15. The base here, B1, is 20. And B2 is 45 minus 20. That's 25. B3 is 70 minus 45. That's 25 as well. So we can go back here and write it out. H is 15 meters per second. B1 is 20 seconds. A1 will be a half B1H, and that will be 20 times 15 over 2, and that gives 150 meter. Next one is B2 equals 25 seconds. A2 will be HB2. We know H is 15 meters per second. That will be 15 times 25. That's 375 meters. A3 will be a half B3H, and that equals to, well, we know B3 is 25, H is 15, a half of those will give you 187.5 meters. So we need to find the total area now, because we need to add all 3 together. Total area will be A1 plus A2 plus A3, and that would be 150 plus 375 plus 187.5, and that came up to 712.5 meters. That's what's expected here. So about 710 meters. We go 712.5 meters. That's good. Part 3. Calculate the average speed of the car for the total distance travel. We know that's the total distance travel, right? So average speed will be total distance over time. We plug in the data, the values. The time is 70 seconds, right? Because you go from 0 to 70. And we get 10.2 meters per second. So we put here 10.2. At B, the inertial mass of an object is a measure of how difficult it is to change the velocity of the object. A force of 450 newtons acts on a car to give the car an acceleration of 0.3 meters per second squared. Calculate the inertial mass of the car. We know that force equals ma, Newton's second law. We can make m the subject. That will be force over a divided by a divided by a cancel out. You're going to get m equals F over a. We know what the force is, 450 newtons. We know the acceleration, and then we get 1300 kilogram. Part C. Figure 12 shows a different velocity time graph. The straight line graph can be represented by the equation y equals mx plus c. So your y is the velocity in meters per second. we got your x, that's your time in seconds. Give the quantities that x and y represent in the equation. Well, this is your x-axis, so that's your time. So we write time there, and your y-axis will represent the velocity. Part 2, calculate the value of m from the graph in figure 12. Well, in order to find the value of m is the gradient. So first thing we need to do is select 2 points. Point 1, point number 2. So we selected 2 points on the straight line in order to find the gradient. Then you turn that point into a right angle triangle. So that is the right angle triangle there. And then you want to find the coordinates of the point. The coordinate here is t1 equal to 0 and v1 equals to 0. That's the coordinate 0, 0. Choose that point. So the coordinate there will be point number 2, and the coordinate will be t2 because it's point number 2 equals the time is 120. So you can see there 120, and v2, this is velocity, is 25 meters over seconds, 120 seconds. Now we can work out the gradient. The gradient is actually the acceleration, because gradient of a velocity time graph is acceleration. So that is change in velocity over change in time. There's a little delta here, that's a delta. It means small change, delta v over delta t. And what that meant is final velocity minus initial velocity, v2 minus v1. Final time minus initial time, t2 minus t1. We know that from our coordinates. We know that v2 is 25, v1 is 0, t2 is 120, t1 is 0, and that gives 25 over 120. That equals 0.21, so that is 0.21 meters per second squared. Part 3 states the value of c from the graph in figure 12, where we can see c is the intercept on the y-axis. The intercept on the y-axis is 0. Therefore, we'll say c equal to 0.